In this example, we have been asked to solve a logarithmic equation. Notice it's definitely a logarithmic equation because we have a log base 3 function and we have an unknown variable x as the argument. There are two different log equations that you want to watch for. The first is like this one, and it's where some of your terms contain a log and then there will be at least one constant term that does not contain a log. If that's the situation, you will solve it the way I'm about to show you. Other log equations contain logs on every single term. Those you will solve a totally different way. I've made a note here. Always check to make sure that solutions you get are in the domain of the function. What I actually mean there is be sure that whatever x value you get does not make the argument of your log negative. So be sure x value does not make argument, and you may have to check it into more than one argument, negative. Remember that you cannot take logs of negative numbers. If you have a log equation like this particular one that has a constant value, the first thing you want to do is get a single log on the left-hand side. That's already done for us. The second thing you want to do is you want to convert this log to an exponential equation. So I will make a note to convert to an exponential equation. To do this, we start at the base of our log, use the result on the other side as our power, and then set that equal to our argument. Okay, we've done this before, but in a different context. But to convert this, this would be 3 to the negative 2 equals x. This is a relatively simple log equation to solve, and we see here when we convert it, we've actually already solved it for x. The x is on one side by itself, and all we need to do is rewrite this and get rid of that negative exponent that's on the 3. Remember that a negative exponent can be rewritten as 1 over the base to a positive exponent. And so this particular problem would result in x equaling 1 over 9. Notice here that the original argument on my log was x. And so what you need to do is make sure that if you plug that value back in to your argument, that it results in a positive value. It does. If I plug 1/9 in for x, 1/9 in for x would result in a positive value. So this answer is okay. If it didn't result in a positive value, then in this situation we would have to say no solution since we only had the 1/9.